So these were all types of questions which are going to end in 2022. It's not going to appear in your exams, but you'll be practicing a lot of these questions. So just for the sake of practice, A means 1, 2, and 3 are all correct. B means B means that 1 and 2 are correct. C means 2 and 3 are correct, and D means 1 only is correct. So just for the sake of practice, make sure you remember the key. So anyways, you're supposed to answer this question. And he's saying which statements are correct. Starting with the first one, there's a 3.27 grams of zinc. So how many moles is this? 3.27 grams. So you find the moles, mass divided by the MR or the AR of zinc, which is, I think, which is 65.4. For zinc, we can open the periodic table or the data booklet. You can make sure 9701 data booklet, this data booklet, always keep it with you or have it printed. So here's a periodic table. And we're looking for zinc, which is 65.4. So zinc is 65.4 and you find the moles. Can anyone tell me what the moles are? In this case, where's my calculator? Just a second. What is 3.27 divided by 65.4? That gives you 0.05 moles. So I've got, the first statement says that I've got 0.05 moles of, zinc. And he's saying it reacts with an excess of hydrochloric acid to give 0.05 moles of zinc chloride. So it's 1:1. Zinc and zinc chloride is 1:1. So theoretically, you should get 0.05 moles. So there is absolutely nothing wrong with the first statement. The first statement is absolutely correct. Is this clear? So is this clear? Amna, Mars, is this clear about the first statement?
Yes.
So the second one states that you've got 6.54 grams of zinc. Quickly find the moles. How many moles you got? You got 6.54, divide that by 65.4, and you're going to get 0.1 moles. So now the second statement states, okay, let's rub this off for the second statement. The first one is correct. So you got 0.1 moles of zinc now. Okay, that is what the second statement is saying. And he's saying it reacts completely with 100 cm cube of 1 mole per dm cube. Now, based on the equation states that it's 1:2. So the amount of HCl, if this is 0.1 moles, the amount of HCl must be 0.2 moles. I mean, you need 0.2 moles of HCl for a complete reaction, 1:2. So he's saying that it reacts completely with this 100 cm cube of 1 mole per dm cube. If you use moles is equal to concentration times volume, you'll find the moles. So it's going to be 100 into 1, except it's also going to be divided by 100 into 0.1. But the cm cube should be in dm cube, so you divide by 1000 and you get 0.01 moles. So I think my first one was actually 0.01 moles. Can somebody double check this one?
Yeah, it's 0.1 moles.
Need this one. What do you get for this? Mass kya aa raha hai for this one?
Sir, ये volume का वही same volume use कर.
हाँ, मतलब उससे he's given you the volume, he's given you the concentration. He's saying that this is 0.1 moles. I mean, the amount of zinc that you're getting, that's 0.1 moles, right? TK, we did the calculation. 6.54 divided by 65.4 mass divided by MR or AR. You're getting 0.1 moles. I want to find out how much moles is this? 100 cm cube, 1 mole per dm cube. What do you get? I mean, this would be 0.1 dm cube. I mean, my desktop calculator doesn't really work properly, so it would be 0.1 dm cube into the concentration, so it's going to be 0.1 moles. So the second statement is saying that 0.1 moles of zinc should react with 0.1 moles of hydrochloric acid, which is incorrect because the equation is saying that 0.1 moles would react with 0.2. It's 1:2. So the second statement appears to be incorrect. Is this clear that the second statement is incorrect? Izhan, is this clear? Raid, is this clear?
So can you repeat again? How did
Yes,
you
sir.
find the number of moles?
For hydrochloric acid,
Yeah.
he gave us the volume of the acid plus the concentration of the acid. Remember, there are basically four formulas for moles, or the three main ones. You got moles is equal to mass divided by the AR or MR of the substance. You've got moles, if it's a solution, then it's concentration times volume, which we're going to do over here because we have it's a solution hydrochloric acid. You have the concentration is 1 mole per dm cube and you have the volume as well. But the volume must always be in dm cube, so it should be divided by 1000. Is that clear?
Yes.
And there's a third formula for moles, which is for gases, that it is volume of gas divided by 24 dm cube, but that only works if at RTP, at room temperature and pressure. So these are the three main formulas. There's another moles formula which is number of particles divided by the Avogadro's constant. Once again. So there's another one which is the number of particles divided by the Avogadro's constant, which is 6.02 times 10 power 23. Okay, so it's the number of particles divided by the Avogadro's constant. So in total, you have these 4 moles formulas. And the equation deals in moles, like what quantity of zinc reacts with what quantity of HCl. But anyways, in the second statement, we got 0.1 moles of zinc reacting with 0.1 moles of hydrochloric acid, which is not true because according to the equation, the ratio is 1:2. You got 0.1 moles of zinc and they're reacting with 0.2 moles of hydrochloric acid. So the ratio is 1:2, which doesn't fit with this statement. The statement appears to be incorrect. And the last one is, in the last one, he's saying that there is 13.08 grams of zinc. So how many moles is that? We'll quickly find the moles.
0.2 mole.
So you're getting 0.2 moles for this. And he's saying, so I'm going to rub this off. Okay, let's get rid of this. So now in the third statement, I've got 0.2 moles of this. And we need to figure out the volume of H, like it's 1:1, right? So the moles of H2 are going to be exactly the same. It's going to be 0.2 moles as well. That's going to be 0.2 as well. Now, if you have 0.2 moles of hydrogen gas, what's the volume? How do you find the volume of the gas? The volume of the gas is moles multiplied by 24 dm cube. So we're going to multiply this by 24 and we'll find the volume. So what do you get for this? I think it's going to come out to be 4.8. Can somebody confirm this?
Yes, 4.8.
Yes. 4.8.
That's just, so we're getting 4.8 dm cube. He's saying that you should get 9.6 dm cube, which is incorrect. We're supposed to get, if you've got 0.2 moles of zinc, you're going to get 0.2 moles of H2 gas, 1:1. And if you've got 0.2 moles of H2 gas, the volume would be 4.8 dm cube. It's not going to be 9.6 dm cube. So that means option number 2 and option number 3, they're both incorrect. Is this clear, this question? All clear?
Yes.
So only the first statement was actually correct. Let's quickly talk about this question. Remember, you need to find the ratio. You need to have equations with you. You need to know the ratio of the substances. Just like a cooking recipe, you need to know in what ratio they're going to mix together. So in this question, he's asking, you got an ore, which is FeTiO3, and you have to obtain the maximum amount of TiO2. So you have an ore, which is FeTiO3. He's saying, what is the maximum amount of TiO2 obtainable from this ore. So we're trying to extract TiO2. Now, even though the equation is not complete, I mean, you don't have a complete equation. You don't know what happens to Fe, but at least you can figure out the ratio. Like if you have one molecule, it's got 1 Ti. So the amount of TiO2 that can be produced is going to be 1. So from one molecule, you can only get 1. So you kind of know what the ratio is. It's 1 ratio. It's going to be 1:1. I mean, you can't get 2 TiO2s from it because then the Ti would not be balanced. It's going to be 1:1. And the question is, what is the maximum amount of TiO2 obtainable from 19 tons of the ore? So you've got 19 tons. Now, one thing is, since this is an MCQ, so you're only interested in the answer. You're not interested in the working. So you can think of this as 19 grams. Don't do the conversion because I mean, the working isn't even required. So I'm just going to treat 19 as 19 grams. I'm going to try and find the moles mass divided by MR. The MR of FeTiO3 is going to be, make sure you take the exact values. Fe is 55.8. Ti is over here, that's 47.9. So it's going to be 55.8 plus there's 47.9 plus there's 3 oxygen. So that's 16 times 3. So you get your moles mass divided by MR. How many moles are we getting for this? Is there any idea?
$151.7, sir.
1? I mean, this is 151.7, right? The MR.
0.125.
Yes, sir.
Okay. I mean, what's the overall working? 19 grams mass divided by MR. So what's the value?
0.125.
So you're getting 0.125 moles. And it's 1:1. So this would be 0.125 moles as well. And he was asking for the maximum amount of TiO2. Okay, so you have to find mass. So moles is mass divided by MR. Mass would be moles multiplied by MR, which in this case would be 47.9 with 2 oxygens. That's 32. So you'll find the mass. What's the mass that we are getting for this?
9.9875.
Which is approximately 10. 9.9875. That's approximately going to be equal to 10. I just converted the tons into grams. So I'm just going to go back. I got 10 grams, which is basically, I'm just going to replace the grams with tons. So that would be 10. Okay, so I now in the theory questions, if you're doing this as a theory question, you would have to do the conversion. Remember, your moles formulas are in grams. I just used a shortcut. I just ignored the tons. I just did it with thinking of this as 19 grams. I found out the answer, which was coming out to be approximately 19 grams. 10 grams. And I just converted that back into tons, just as a shortcut. But in the theory question, you would have to do the conversion. Like what's 1 ton? Remember that 1 ton is basically 10 to the power 6 grams, because 1 ton is 1000 kg and each kg is 1000 grams. So that's 1000 into 1000. So it's 19 into 10 to the power 6 grams. So if this was a theory question, you had to show the working, then you would have to do the entire conversion, which is 19 into 10 to the power 6 grams over here, divided by the MR. You get the moles, you multiply it by the MR to find mass, and the answer would come out to be in the appropriate quantity. So let's move to the next one, which is what mass of solid residue can be obtained by the thermal decomposition of, yes, Mars?
Sir, we just look only to the Ti. Why we didn't consider the O also?
Either when you're balancing this?
Yes.
Remember, okay, why did I take 1:1? I took it 1:1 because I don't know what's happening. I don't know what's, I mean, there must be something else produced. I don't know what's happening to iron, TK. I don't know what's happening to oxygen, TK. But he's saying TiO2 is formed from FeTiO3. So this would be impossible. Like if the ratio was different, like for example, you had 2 FeTiO3 and they were producing 1 TiO2. This ratio would be impossible. Like there are 2 TIs and over here there's only 1 TI. The TIs must be balanced. Okay, is this point clear? Okay, if you try to balance the TI must be balanced. I mean, we don't know what's happening to the other things. Where did the Fe go? I don't know. Because there must be some other thing that must be formed. Like it must have, I don't know how many Fe's, and it must have some oxygen with it. So I just looked at TI because the TI was extracted. I mean, there was TI in this, and the TI was extracted. The TiO2 was extracted, right? He's saying what is the maximum amount of TiO2 obtainable from FeTiO3. So I was trying to extract that. So if there's 2 TIs over here, there should be 2 TIs over here as well. I mean, the ratio would be exactly the same. So it can't be 2:1. It's got to be 1:1. Maz, is this clear?
Yes, yes, sir.
Okay. So remember, you don't need to know the full equation. You just, even if you have a partial equation, you can still kind of figure out what the ratio is. In this case, it's going to be 1:1. So there's going to be a similar question like this where you didn't know what the whole equation was. For example, I'll just quickly find out that question. Just 1 second. Okay, where you just had some partial information. I think it was this one. No, here the equation is given. Just a second. Definitely over here somewhere. I hope I can find this. Just hold on 1 second. Yeah, actually just wait. This one. For example, I found the question. For example, look at this question. Now, it's a complicated question. You don't know the full equation, but remember, you can't solve a moles question unless you know what the ratio is. Like in what quantity, what's the recipe, what's the ratio, in what ratio should you mix the two things up? Now, in this question, he's saying there's aluminium powder and it's reacting with barium nitrate. So there's aluminium powder and it's reacting with barium nitrate. Okay, so you have this thing and he's saying it's used as a propellant, and metal oxide and nitrogen are the only product. So metal oxides, what are the metal oxides? You'll have aluminium oxide and you'll have barium oxide. And he's saying the metal oxides, these are the 2 metal oxides. And nitrogen are the only product. So you're getting nitrogen gas as well. So here's your equation. Now, even if you try to balance this, at the moment, you will not be able to balance this. I mean, you can try, you can go ahead and try and balance this equation. It's a very difficult equation to balance. It requires techniques that you might not have studied yet. So, I mean, the balancing of this equation is very difficult. So you'll waste a lot of time trying to balance this equation. Try and make an effort. You'll spend hours on this and this equation would still not be balanced. Now, how do you solve a moles question without knowing what the ratios are? The way you're going to do that is you're just going to focus on, he's saying what volume of nitrogen measured under room conditions. So he's only interested in nitrogen, only this thing. But he doesn't care about anything. He's saying what volume of nitrogen measured under room conditions is produced when 0.783 grams of barium nitrate reacts with an excess of aluminium. So barium nitrate, he's saying, what is the volume of nitrogen gas that's produced when 0.783 grams of barium nitrate reacts? So the issue is, I don't even care about what the other ratios are. I don't care what aluminium is. I don't care whether it's balanced or not. I don't care what I'm only interested in is the fact that what is the ratio of this thing to this thing. And I can actually find that ratio because how many nitrogens do I have over here? I've got 2 of them, right? How many nitrogens do I have over here? I've got NO3 twice, so that's 2 nitrogens. So that means whatever happens, whatever way this equation is balanced, these two things are going to have a, I mean, if I can ignore all the other ones, these two are always going to have 1:1. I mean, the ratio would always be 1:1. Because if I try to change this, like if I make this 2 barium nitrates. Now, how many nitrogens I've got? I've got 4 of them, right? So I would have to multiply this by 2 as well. So I would have to multiply this other one with 2 as well. So just to balance the nitrogen, the ratio of this thing to this thing would always be exactly the same. Do you get this point? Yes or no, Sidra? Is this clear? Mars, Ospa, is this clear? Eid?
Yes, sir.
Okay, so the point is you don't have to, because I'm only interested in this thing and I'm only interested in this thing. I don't want to find the ratios of all the other things. So no matter what I do, the nitrogens need to be balanced. Okay, so I'm just focusing on the nitrogen. There are 2 nitrogens here. So there should be 2 nitrogens over here as well. So the ratio would always be exactly the same. And I can show you a balanced equation as well for this one. I mean, this is not a completely balanced equation, but I know what the ratio of this thing to this thing is. There's a balanced equation somewhere given in the previous question, somewhere over here, in an earlier question, for the same reaction. I think it's given over here, this one. So that's the complete balanced equation. But even over here, you can see that the ratio of the barium nitrate and the ratio of nitrogen is 1:1. I mean, it's 3:3, which is kind of 1:1. Because the nitrogens need to be balanced. If there are 6 nitrogens over here, you've got to have 6 nitrogens over here as well. So no matter what numbers come with these things, we don't need to know the entire equation. We just need to know the ratio of the concerned quantities. Is this point clear to everyone?
Yes.
Mahat, Izhan, is this clear? Ospa, is this clear?
Yes.
And I'm going to show you. I'm going to do a few more examples like this. Like if you're given a reaction, and they're saying you've got sodium reacting with phosphoric acid, and it's producing Na3PO4, and it's producing H2 gas as well, right? Now here's a reaction. Now this equation would be balanced very differently, but if the question is only concerned with these 2 things, for example, he gives you a mass of this thing, and he's asking what is the mass of this substance that's going to be obtained. So the ratio is going to come out to be like there are 3 sodiums over here. So there should be 3 sodiums over here. So the ratio would be 3:. I mean, it's going to be 3:1. You don't need to balance the entire equation. By just looking at these 2 things, you need to balance the sodiums. There are 3 sodiums here. There would be 3 sodiums over here as well. So you can save the time. You don't need to balance the entire equation. If this is the ratio that you're just concerned with, don't waste your time trying to balance the whole equation. So it's coming out to be 3:1. We can try and balance the whole equation as well. Okay, I mean, this one is an easy equation. You can kind of balance it. I can try and balance the whole equation. Like there's 2 hydrogens, there are 3 hydrogens, so I can try and balance the whole equation. So I'm going to multiply this by 2, and I'm going to multiply this by 3. So I get 6 hydrogens. Phosphorus becomes 2, so I need to multiply this by 2, and Na becomes 6. So even after balancing, what's the ratio of sodium to what's the ratio of these 2 things? It's 6:2, which is exactly 3:1. Okay, 6:2 is the same as 3:1. So the point I'm trying to make is if balancing is taking a long time, remember this thing, you don't have to balance everything. You just balance, or you just figure out what the ratio of the 2 concerned quantities are. And you just focus on that because he's not asking for aluminum oxide, he's not asking for barium oxide, he's not asking for aluminium. So you don't even care about them, TK. Don't bother wasting time trying to balance aluminium over here, for instance. Got 2 nitrogens here, there should be 2 nitrogens over here, which are already there. So it's 1:1. It's 1:1. So we can just quickly solve the moles question without even balancing the entire equation. So how many moles you got over here? It's mass divided by MR. So mass is given, barium is, I'm not sure, it's 137 something, or it is 137.3 over here. So it's 137.3 plus NO3, that's 14, plus 16 into 3 is 48, plus 14, that's 62. 62 into 2 is 124. So you get this. So can anyone tell me how many moles you're getting mass divided by MR for this one? Has anyone done this? What's the answer?
2.996 multiplied by 10 to raise power minus 3.
Okay, so I'm just going to round it off to 3 times 10 to the power minus 6. Minus 6? It's not 3.
Minus 3.
That's a
3.
minus.
Minus 3.
So you're getting 3 into 10 to the power minus 3 moles, right? So 1:1, so this would be 3 times 10 to the power minus 3 moles as well. So you're getting this much, and he's asking for the volume of nitrogen gas that's produced. So you multiply it by 24 dmq. What do you get for this? 7.2. What do you get?
So 72 centimeters.
Okay, you're going to get your answer in dm cube, and that would be converted into cm cube. So it's going to be 72 cm cube. So the whole point is, just remember the whole ratio doesn't, for example, they give you a question that a metal reacts with an acid like phosphoric acid. So there's a metal that's reacting with a phosphoric acid. You don't know what the metal is. And they're saying that metal reacts and produces a salt. You have no idea what the metal is, and you have no idea what the charge on M is. But he's saying that it produces a salt plus H2 gas, right? And they're saying they've given you the moles of the phosphoric acid, and they're asking you to find the volume of H2 gas. So we don't even care what the metal is. We don't care what the salt that's being produced. We can find out the ratio of these two things. The ratio would be that the H atoms must be balanced. So 6 hydrogens. So I'm going to multiply this by 3, and I'll have 6 hydrogens over here as well. So that means the ratio is 2:3. So without even knowing the full equation, without even balancing the whole equation, I can still find out the ratio of 2 of the substances in the equation. Is this clear? Yes.
Yes, sir.
So you can kind of still figure that out. Now, going back to the question. Okay, so just don't waste time balancing difficult equations. Just focus on the things that need to be balanced. So coming back to the question that we were on, so let's try and do this one. So again, it's a simple question. You've got magnesium nitrate. It will decompose when heated to give a white solid. So I'm just going to guide you quickly, TK, without solving this. We'll just skip questions now, the easy ones. Remember, nitrates decompose, they produce magnesium oxide plus NO2 plus half O2. What are you going to do? You're given the mass of what? Magnesium nitrate. Anhydrous means there's no water, so that's fine. You'll find the moles, 29.7 divided by the MR, you'll find the moles, right? And he's asking, what is the mass of oxygen that's produced? So once you find the moles of this thing, you can use ratios and find the moles of this thing over here. So it's in this case, it's 1:half. So you can find the moles of O2. Okay, we can do that quickly. So I've got 29.7, and the MR of magnesium nitrate I think is 24 plus. Well, I think it's 148. Okay, just quickly. You get these many moles, and remember the moles of oxen are half of this. Okay, so it's going to be half of this. So I'm going to multiply that by 0.5. And he's asking, so I get this number, and I'm being asked to find out the mass of oxen. Oxen has an MR of 32, so I'm going to multiply that by 32, and I get 3.2108 grams, which rounds off to 3.2 grams. So moles of this, you find the moles of this, and you find the mass of this. Okay, is this clear?
Yes.
So then about these two compounds, there's some equations you wouldn't know. Okay, I mean, which you haven't studied in ACE. So this is one example. So don't worry about the equations. You'll do that later on. So I'll give you the equation for this one. You've got 0.125 moles of chlorine, and it's reacted with cold aqueous NaOH. So this is an equation that you have to remember. You're going to study this in inorganic. So it reacts with cold NaOH, and when it reacts with cold NaOH, it produces NaCl. This would be 2. It would produce NaClO, and it's going to produce H2O. So that's the whole reaction. So there's 0.125 moles of chlorine. So you got 0.125 moles of chlorine. And what is he asking? What is the mass? One of the product is a compound of sodium, oxygen, and chlorine. So he's talking about this one. So he's saying what mass of this product is formed. So we need to find the mass of this thing. It's 1:1. So that's kind of easy. Same moles, 0.125 moles. This would also be 0.125 moles, 1:1. And you have to find the mass. You just multiply it by the MR of this thing, and you'll find the mass. Is this clear?
Yes.
The other one is a similar type of questions. This one as well. This one is you're given 5.4 grams of aluminium powder. So you can find the moles of aluminium. 5.4 divided by 27, which is the AR of aluminium. So you do that, 5.4 divided by 27, and you get 0.2 moles. So in this case, you are getting 0.2 moles. What is he asking? He's asking, it reacts with an excess. What mass of barium oxide is produced? So he's asking about the mass of this thing. Now the ratio is 10:3. So the mole ratio is going to be exactly the same, 10:3. So it's going to be 0.2 divided by 10 into 3. Or you can use the ratios, but the shortcut is 0.2 divided by 10. Divide that by its ratio and multiply it by the ratio of the other substance, which is 3. So what's 0.2 divided by 10 into 3? That would give you 0.2 divided by 10 and then into 3. That would give you 0.06 moles. So the moles of barium oxide come out to be 0.06 moles according to the ratio 10:3. And we have to find the mass of barium oxide. So we have the moles now. All you have to do is multiply the moles by the MR, which in this case is 137.3 and oxygen is 16. You do that, you'll find the mass, which you can calculate on your own. Okay, is this clear as well?
Yes, sir.
Okay, so let's do another one. Okay, keep your calculators with you. He's saying there's this sodium azide that liberates nitrogen gas. So I think he's talking about this thing. This is your sodium azide that's fitted in airbags, and it liberates nitrogen gas. So nitrogen gas is produced. So this is sodium azide. You've got 50 grams of sodium azide. Can you find the moles of sodium azide? Can anyone quickly tell me what the moles are? 50 grams. Everyone try and calculate this quickly. I'm going to tell you the AR value. Sodium is 23 and nitrogen is 14. What do you get for this?
.769.
Okay, so you're getting 0.769 moles for this. Okay, remember the whole question of whole moles question is you just have to find the moles of one thing. Then you'll be able to find the moles of everything in the equation using ratios. So you get 0.769 moles of this. What is he asking? He's asking you to find the volume of nitrogen gas. So you can find the moles of nitrogen gas. How do you find the moles? Use ratios, 2:3. And the faster way is 0.769 divided by 2 divided by its ratio multiplied by the ratio of the other substance. So 0.769 divided by 2 into 3, you'll find the moles of N2. So can anyone tell me what are those moles? 0.769 divided by 2 into 3.
1.194.
Okay, so you're getting 1.194 moles. And he's asking you to find the volume. TK, be quick. Volume of nitrogen gas, that would be multiplied by 24 dm cubed. That's it. So remember, be very quick. Try and do this as quickly as possible. So what are we getting?
28.7 after rounding.
28.7, I think. Why is it so off?
0.656.
But that's like really off. I mean, because it's very far away. I mean, it's going to be, I think it's going to be C. Yeah. Yes.
1.154 moles the sir.
Acha, theek hai. I mean, this was 1.154 moles. Theek hai. Double check this. Now you're going to get 27.7. So just remember that make sure all those formulas are on your fingertips. Okay, if you want to do something like very, very quickly, do things very quickly. Okay, try and, I mean, these formulas, you need to find mass, multiply the moles by the MR. You need to find moles, divide the mass by the MR. You need to find volume. I mean, keep practicing this. You have to be very quick with this. You need to find the moles of this gas divided by 24. So what's 3 divided by 24? I think that would be what? 1 by 8, which is 0.125. I think, can somebody tell me, is that the correct value?
Yes.
Okay. So even you should be good with your mental math as well. I mean, some fractions you without wasting time, because you're always short of time in A levels. So what mass of gas would occupy the same volume as 3 dm cube? What mass of gas would occupy a volume of 3 dm cube? So it's these many moles. So we need to find the right moles, like 0.125 moles is going to occupy this much volume. So how many moles is this? The mass is given. So 3.2 divided by 32. So that would give you, I mean, oxygen has an MR of 32. So that would give you, I think, 0.1 moles. So that's wrong, because 0.125 moles of gas occupies a volume of 3 dm cube. If you have got 5.6 grams of nitrogen, so that would be N2, 14 plus 14, that's 28. So I think that would be what? 0.2 moles. So that is also incorrect. If I do the third one, C, that's 8 grams divided by sulfur dioxide, that's going to be, sulfur is 32 plus 16 plus 16, that's 64. That is going to come out to be 1 by 8, which would be 0.125 moles. So he was asking which of these gases would occupy this much volume. So I found out the moles, that if it has this much moles, it's going to occupy this much volume. So 0.125 moles, it's going to be C. Is this clear? Gmaz.
Sir, why did we divide 3 by 24? I couldn't get this.
Moles. How do you find moles for a gas? Malib, there's a gas that occupies a volume of 3 dm cube. So how many moles is this? Volume of gas divided by
24. Yeah, I got.
Okay, so you found the moles, right? So you found the moles. So you know okay, whichever gas occupies 3 dm cube must have this much moles. So I started finding the moles. Okay, he had given me the masses of these gases. So mass divided by MR, it should have the same moles, 0.125 moles. Like if I try and multiply this by 24 dm cube, I'm going to get 3 dm cube, which is what he was looking for. Which gas would occupy 3 dm cube? So it's going to be C. So let's try and do more questions related to moles. Progressively, we're going to start focusing on more difficult questions. Okay? These are the easy ones, but make sure the formulas are on your fingertips. Volume of gas, what do you do with that? Mass is given, what do you do with that? Concentration is given, what do you do with that? Okay? So make sure all these the 3 main formulas are on your fingertips. So let's continue tomorrow then. Okay? Okay, everyone.
सर
Okay, sir.
जी
सर ये वर्कशीट शेयर कर देंगे सर
हाँ ये मैं शेयर कर रहा हूँ ठीक है अभी कर रहा हूँ ठीक है ओके अल्लाह हाफिज
अल्लाह हाफिज़
Okay, sir.